body of mass 4 kilograms at rest on a table is acted on by a horizontal force G. The body just begins to move when G is 12 newtons. Calculate the coefficient of friction between the body and the table. All right, so they're looking for mu, the coefficient of friction, and we know that the frictional force, which opposes motion, is equal to mu times the normal force, okay? And if something's at rest on a table or on a surface, we're going to have a normal force acting on it. So let's draw our picture of what this thing looks like. Okay, so we've got a body and it's on a table. It weighs 4 kilograms. It has a mass of 4 kilograms. So it's going to have a weight force acting down. And because it's resting on the table, we're going to have a normal force acting directly up. Now, if we're going to move this object, it says there is a horizontal force G acting on it. So let's put, doesn't really matter which way around you put your G. And they've said that when it's 12 newtons, the object will just start moving. That means it is just able to overcome the frictional force. Now, frictional force, let's put acting in the opposite direction to motion. And remember, we need to do our reference axes so that we know which direction our I's and our J's are in. All right, let's define all of our variables. So we're going to let R be the resultant force in newtons. We're going to let N be the normal force in newtons. We'll let W be the weight force in newtons. We'll let G be the applied force in newtons, and we'll let F be the frictional force in newtons. All right, we've defined all our variables, and we also need to acknowledge that we know that because it hasn't moved yet, our object is in equilibrium. Okay, so object is about to move, so therefore it's still stationary, therefore object is in equilibrium. So that means that my resultant force is 0. Okay, it's important that we do that. All right, let's write all of our forces. So R is 0I plus 0J. Our normal force, we don't know what that is yet, but it's acting in the positive J direction, so it's just going to be NJ. Our weight force is acting in the negative J direction, so that'll be negative WJ. Now, we know that W is mass times gravity, so that's going to need to be W negative 4 times 9.8 J. Okay, our G is acting only in the I direction, and it's in the positive I direction, so that's going to be 12I, and F is acting in the opposite direction to I, so it must be negative Fi. All right, let's put all of this together. We know that R is equal to N plus G plus W plus F. R is the sum of all your forces. So 0I plus 0J is equal to NJ plus 12i minus 4 times 9.8 j minus fi. All right, and I can collect all my I and j components. So 0i plus 0j is going to be 12 minus, and 4 times 9.8 is 39.2. Oh no, that's not an I. Hang on. We're wanting our i's first, so we're going to have minus fi, and then plus n minus our 39.2 j. All right, now I've got my I and j components. I'm going to equate my I and j components, and that then gives me that 0 is 12 minus f, and f is 12 newtons, and 0 is n minus 39.2, so n is 39.2 newtons. But now we still haven't answered our question. They're looking for the coefficient of friction, okay? And we know that F is mu n, okay? And you need to know that formula. Okay, so our frictional force is mu times our normal force. I've worked out my frictional force. That's 12 is mu times 39.2. So mu is 0.306. No units of measure, and 3 or 4 decimal places is fine.